Hello. Welcome to DevOps and continuous integration with JavaScript. The title of my talk is Delivering Somewhat Continuously. So my name is Jeff Labonski. You may remember me from 15 minutes ago. And so I'm still a consultant at Chariot Solutions. And I'm, unlike a recent JavaScript convert, I'm also a hardcore DevOps believer. So, you know, one neat thing about DevOps is that once you pop, you can't stop. It starts to make other processes look really, really slow and antiquated and somewhat problematic. And it's a nice mode of thought to get into. And there's an awful lot of benefits to getting into a DevOps mindset, even outside of the JavaScript frameworks. But we'll be taking a bit of a close look in leveraging this for JavaScript, client-side and server, and some of the fun things you can do for making developers' lives slightly more miserable and annoying the crap out of operations at the same time. So it's like a win-win in that perspective. So, I mean, DevOps is right now chronically misunderstood. It's been watered down to the point of being almost unbelievable. And you end up with, you know, these really nice WordPress templated websites with a happy stock photo of things, people doing things, and they say, did DevOps. And so like sales and marketing gets a hold of a term and suddenly it's applicable to everything. And they repeat it enough that you end up, the term almost becomes meaningless. So for a lot of people, DevOps means I do scripting sometimes, or I do system administration and I write a little bit of Python on the side. But you know, the topic has been kind of beaten to death, much like SOA was, like the cloud, if anybody remembers that. And most recently blockchain, which was just like comically distorted beyond all forms of recognition. So DevOps. So, I mean, what is DevOps? And I'm going to start with a little bit of philosophy. And now's a fantastic time to leave the room and go take a breath of fresh air if you'd like. The concept of DevOps, much like the concept of Agile doesn't mean you bought Jira. It means you're doing something, right? DevOps doesn't mean that you write Python now in your spare time. You're doing something. So, I mean, the fundamental thing with DevOps is that this is a people problem. So DevOps is attempting to address the problem of siloed teams, siloed individuals, institutional knowledge, the handoff and transfer of information between team to team, isolation, and all that jazz with that. So you mean you have this problem like ops hates dev because dev does crappy code and they got to make. There are the guys up on Friday night sitting at home because they're on call, and they have an axe to grind. Dev doesn't really even matter because they, the jar is perfect. What's going on? It's not my fault. Oh, it's a little bug. We'll get to it later. The DBAs hate everybody. So on occasion, security will swoop in, do an audit, say the architecture is broken. Please rewrite it from scratch. Or more frequently, there is no security to swoop in, and then you learn about it on Pastebin, which is kind of terrible. And the testers are all just weeping the entire process through. So your standard enterprise, right? So, I mean, the problem with this is DevOps is trying to collapse the team together. You have dev and ops together on the team, and they're concerned about the one thing is the product and getting that product out and working well. That really is the kind of like the core of what DevOps is supposed to be about. And it's also about this process. It's this idea of continuously improving things, automating things as much as humanly possible, getting rid of the human element where errors can occur. So reducing steps, reducing manual interventions, and testing. I mean, it kind of almost goes without saying, but it's important to reiterate that testing is absolutely integral to this. So people talk about continuous delivery like it's something they're going to do on Thursday. It's something that's going to take years to accomplish for any project. And you have to have the testing systems in place like day one moving forward to get there. You can continuously deliver, but you'll just deliver terrible things. And so it's also a bit about a philosophy. So this is a way of thinking about things. Improve, communicate, deliver better, take ownership of what you're delivering, the whole thing, not just the code, not just the server, the experience, how the user interacts, how happy they are, hopefully that they're buying them whatever you're selling, or using whatever goods and or services your company produces. Learn and fail, and then learn again. So really one of the neat things about this, though you can kind of consider like a kernel, and again, in my opinion, so this is Jeff's understanding of truth, is this concept of a blameless postmortem. So this is a philosophical goal to strive for. So this is when the whole thing falls flat on its face in a terrible, terrible way, and you dust yourself off and you fix it. Now, what happened? How can we learn? How can we learn without fear of getting fired, which is an important thing. So processes can be reviewed, lessons are shared, processes can be tightened up, whatever introduced to failures can be mitigated, and you can begin looking for additional failure modes in the same vein. Learning from this is important. So being able to have a blameless postmortem is a cultural issue and hard to do. When you get there, it's really nice. The benefit is that you're not in a cover your rear end perspective. Engineering is not defensive against ops, is not defensive against marketing, is not defensive, so on and so forth. If everybody's in the same boat, you all got to row in the same direction. Things go wrong, as they invariably do, and you learn from it and try to recover and improve and move on with your life. So it's nice to say, like, I failed and I learned, as opposed to, we failed and the relevant person has been disciplined, which doesn't actually solve a whole lot. So, and really what it's not this title. I've got a bunch of friends who are system administrators and now they're DevOps engineers and they don't really even know why. Half of them are also site reliability engineers as well. That's a fancy title for system. So DevOps is not a title. It's actually something you're trying to do. You're not going to get a cert in it. You can't spend a couple grand in a weekend and suddenly become, Captain DevOps. You can't buy it. It's not for sale. If it is, double check your credit card details. It certainly is not easy. It's really for certain. And it's not implementable the way we think of it as in engineering. So you must change your process. This is a process-oriented system, and it tends to come from the top down. And it's worthwhile trying to fight for if you can. You can see a lot of benefit on having closer integration between stakeholders with different domain knowledge. That should be really relevant, apparently relevant to doing your work. Not having any kind of knowledge on the team on how it's deployed means that it won't be deployed correctly. The two pieces intersect. Same thing for databases and development, the same thing for security. The same thing goes also for design as well. Having these teams integrated gives a wealth of knowledge, and also a lot of people can cross-learn and generally increases quality and deliverable speed very, very well. So change comes from within. You just can't pick it up somewhere. But one of the neat things is, and why I particularly love being a software engineer, this is what, software is this fantastic thing. We're in this really neat place in history where we can think about things and then do them, which is awesome. So building software and then rebuilding it is free. It just takes a little bit of time, which admittedly is money, but it's a lot less cheaper than steel. So if you're working in an industry that had a tangible good that was being created and you started messing with it, eventually an accountant will come by and start yelling about CapEx and COGS and other acronyms that you're kind of reducing the bottom line by wasting materials. Software, you can goof and then be back up in like 5 minutes or even less. It's fantastic because it's so quick to iterate, it's so quick to implement, and it's so quick to change and repair. So I've always kind of feel like this is how like a chemical engineer in Germany in 1800 felt. Like, it's this new era we're in, software engineering. It's fantastic. And it's a lot of fun. The downside is that as a species, we literally have no idea how to build software. So like I can build a bridge and I can say, when I hit this on the Richter scale, bridge gonna go down. Don't go on bridge bad. The cutting edge coming out of the journals today on the ACM and the IEEE is really just how to screw up less frequently, if possible. So we're still learning as we go. There's no, gold standard on how to build software yet. Which is great because it means that we'll all be employed forever. And the journey for DevOps takes a while. It's not something instantaneous. You can't flick a switch. You can't just say, Monday, we're going to DevOps everything. And I'm kind of always been, somebody mentioned the term continuous quality. And I always like that. So before continuous delivery, you must have continuous quality. And that takes a long time. Once your code coverage and test exceeds several 100%, you may feel like you're kind of getting there. Both for unit end-to-end and full integration testing. So when you're talking about your tests exceed your quantity of actual running code, now you're getting to a neat little place. That starts to unlock continuous delivery. So none of these things come quick, believe me. Even the big players, these take years and years and years to implement. And so, obviously, you can't go out and act today. So there is a disclaimer on that. But having talked about philosophy and being boring, let's actually do some fun things. So everybody came here to talk about the DevOpses, so we're going to bring out a couple DevOpses and get some tangible results. So one of the main things is you can't trust developers. So, they're all lazy and they write bad code. And this is true for everybody, right? With potentially the notable exception of a couple great luminaries. Everybody's lazy and writes bad code. So let's work to prevent that as much as we can. So one of the major things is to begin leveraging your tool chains as much as humanly possible. So if you have a compilation step you're writing in TypeScript, take a look at your tsconfig. Read the whole documentation from beginning to end. Turn on every flag that you can possibly find, and turn all warnings into errors so that you can't compile. Set up as many guardrails as humanly possible. The compilers by default are very forgiving, and they tend to be interpretive with what actually source code is. The problem is that the machine's interpretation may not be that of the developers. They may have different concepts involved. You can tighten this down a whole lot. My favorite is no implicit any in TypeScript, which is always my friend. You can turn all these things off and make sure, when you want to type, you're actually saying any, or you're not just flubbing your type system, which is the whole point of TypeScript. There's all these little knobs you can turn and tweak on the compilation steps. On React, the prop types, again, anytime that you're seeing actions moving through a system where you're getting generated code targets out, turn everything on as much as possible. There used to be a few knobs and bells and whistles on Babel and Minify, but they've greatly simplified the process lately and really just turns on. But old school, there are a few flags you can kind of turn on and just catch anything that might be strange that came across the wire. The problem is that most things, these tools emit a warning, they say, man, that's a little funny. It probably terribly is. You may be missing polyfills. You may be performing slightly illegal actions. So it's better to learn early than later when it's in prod. And leverage all your tool chains. So lint, and lint. TSLint, ESLint, everything a lint. Never stop linting. So TSLint's fantastic. You can turn the pedantic, I hate all people and all things, all the way up to 11. And it'll get you on the straight and narrow real fast. I almost highly recommend it. Turn everything on and then dial back when things become disturbing, when you actually can't write code. So some things may be completely at odds. It'll yell at you because you put semicolons in. You take them out, it'll yell at you because there are no semicolons. One of the rules is, you got an old rule rattling around, zap it, move on. But mainly, turn all the linters on. They pick all the fluff out of the program. And there's tons of linters. People think, to turn on TSLint, I'm done. No, there's one for the package.json file. So make sure I'm getting everything right. If I choose to publish, I will do it right. And my email address will show up in the right field when people need to complain. So this will keep an eye on that nobody's messing up your package.json file, which is kind of really important when you're publishing it. There's this guy, NPM audit. It's been in the news lately. Keep an eye on security failures. Node comically rots very quickly. Code that you wrote 6 months ago probably has a couple dozen remote denial of services just rattling around in some base libraries already, just by sitting there practically. NPM audit keeps an eye on the security aspects of the code that you're writing and have written. There's paid-for tools we've used before in the past. I'm not endorsing them, but they seem kind of nice. They'll actually mitigate a lot of security problems out there. Introduce their own, but it mitigates others. There's a linter for Markdown that kind of comically complained about the spacing around all my headers today. So I attached the Markdown lint to the slides when I was writing them. It let me know that I was a very bad person and didn't know Markdown. But it was nice because at the end of the day, all of my Markdown is compliant, and now I know at least it'll be able to be viewed in practically every Markdown viewer on the planet, which is fantastic. And I don't really recommend it, but we had one project where we were speaking Node to SQL Server, which is a very interesting marriage of technologies. And so there's actually a T-SQL lint built in NPM. It used to be a Java project, but you can just do a quick NPM install of it, and it'll check your SQL files to make sure you're conforming to the best practices for the T-SQL standard for SQL Server 2008 and ahead. That is awesome if you don't write a whole lot of SQL Server 2008 and above. It's going to keep tabs on doing really bad joins, table scans, potentially doing really nasty things that'll get the database to fall flat on its face. Bitsword's kind of like having a pocket DBA kind of hanging around. There are tons of these programs and linters and checkers out that you can leverage. Just keep an eye out for them, see what else is available. You may be pleasantly surprised or kind of like disturbed actually, again, finding a SQL Server linter in NPM. Okay, now I've seen practically everything. So never not stop adding quality checks. Keep them coming. If you find something new, pop it in there. Browsing GitHub, you're reading source code because the library documentation sucks, and you see that they're using a new tool, take a look. So I was pleasantly surprised by some of the bits that I've just found kind of rambling around. Graft into your project and keep going. Keep raising quality as much as you can. So other things that are kind of neat is SonarQube. They do JavaScript work as well, in addition to the whole Java side of things. Most of these things have plugin capabilities. You can extend your own rules as needed. Even write your own. There's nothing wrong with slapping a few regexes together and parsing source code and just looking for a smell if you happen to keep running against it over and over again as well. And don't let the language stop you. There's a tool in Java, you can run it. There's an NPM package called JDeploy, which wraps the JVM. Kind of neat. You can slap it as a dev dependency and run Java programs in the tool chain without actually shipping it. So you have a lot of the power available to the operating system and the scripting environments to leverage a ton of different tools available. So as you see fit and as your level of being evil to developers kind of grows and wanes. So eventually you end up with this weird bit like a script block in NPM. We have tons of these little programs all lined up in a queue, which is great. So one of the nice things to do is bundle these all up into a single flight, like a pre-flight target or something like that the developers can run. Just something real easy. Just shows them all of the tests all concatenated one after the other and say if this runs and nothing screams, things are probably pretty good. So we're going to tie this together with preventing engineering from doing bad things to everybody else, the repository. We're going to do that through a few quality gates. So like I said, a lot of this stuff is just kind of standard stuff, but it's really important putting these tools together to raise the bar of quality as a project is moving forward in the commit cycle. So we're going to go and protect the actual Git repo as much as we can. And again, you can tweak all of this depending upon how evil you feel like or what kind of targets you're trying to get on your team's code there. So a lot of these things are going to be based off a Bitbucket pipeline. I'm not endorsing them. I don't make any money. It's just a technology stack that I'm really familiar with. And for the purposes of this demo, it cost me $5. So I've done a lot of this work with Jenkins. There's other alternatives like Circle CI, Travis, et cetera, You can put these all together fairly easily. So I like Bitbucket. It's integrated into Jira. They talk very well to each other. And it's not too terrible of a product. But the one nice thing is, so you write this little YAML file here for the pipelines, pipelines.yaml. And again, this is all checked into the SPA-day server. So you can feel free to take a look at it. And it actually was integrated into the build process while we were building it. So we dog-fooded this during the development for today. And so it's real simple. It just says basically every branch, there's a default step, and does this npm install, checks to make sure my package is there, runs the linters, verifies SQL, runs the unit tests, et cetera. And so this happens every commit, which is kind of neat. So at the top, you can see this little node stable. It's just really a Docker tag. So nice thing is this all spins up through there on the servers. You get a fresh server every time. You can pick what runtime it is, whether it's Node, Java, Python, whatever, and execute whatever you feel like in it. And so they just check your source code into it, and you're off to the races. And so these script tags are just command line whatever. So you can do an rm-rf if you really felt like it. So the whole power of the Unix system under this particular Docker image is available for you. Not to scare everybody off with Docker just yet. I'll scare you all off with it later in the presentation. And so you can kind of bind this together with branch permissions on the Git side. So Bitbucket has this neat little UI. So I'm going to protect my main development branch called develop. I'm going to say nobody has access to write to it. So you may not write to this branch at all. You may only communicate via pull requests, which is nice. The reason why it's nice is that I can implement all these interesting quality gates to it. And I can say that I must have 2 peers approve the pull request before it'll enter in. So I can force a peer review process into play and keep the developer pool engaged in reviewing each other's code. At the very bottom here, you can see that I want to check to make sure that the build has succeeded at least once, and there are no failed builds. And this is neat because all of those NPM targets and linters that I previously installed now are running in every feature branch before it gets to my main development branch. So I have this quality gate that I've erected here. Say not only you will not get into mainline development until you have mandatorily run, well, it runs it for you, all of the tests, all of the linters, all the unit tests, integration tests, spun it all up, made sure the compilation works fine. And you can do other fun things with code coverage tests and other pieces of analysis. And somebody has at least eyeballed this and it's not glaring and doing something really comically bad or weird out there. So these can be raised. There's a lot of plugins for Bitbucket. More if you host it, less in the cloud. You can do some fun things like saying, if this particular module, I must have a manager sign off, which sounds terrible, but it's important if you have institutional requirements such as SOX compliance and other things like that. There's a lot of flexibility involved with that. That could be kind of nice. And so I just wanted to give a bit of a brief of, well, when we collapse all the commit history, you won't see this again, but failed builds on the SPA-day server. So again, this is just, we're up to build, on this screenshot, build 26. So if I have 26 commits in, thud, 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 couple breaks here and there. Predominantly lint, I won't mention who did it, but they were very bad at their linting. And so you can see that this is automatically, every time the commit's coming through, the tree's going red or the tree's going green, which is great. So if anybody here who's been doing this for way too long, anybody remember Bonsai? Oh, never mind. Okay. I'm showing my age from the 90s here on this kind of stuff. But they used to, when they were building Mozilla back when it was new, brand new, they'd have a whole series of build systems going through, and they would just basically, the tree goes red and catches on fire. Somebody would do a bad commit, and it would blow the entire distributed development network across the world. They would all just stop. At least they were building, right? This prevents that from happening. It prevents you from poisoning branches by keeping the tests out in feature branches in Git, which is actually really kind of neat. And so you can always dive down on this. And so we could take a look at an individual pipeline, and I'll show you the actual lint errors and all the NPM goop at the end. But yeah, okay. So now I am, rather comically, I am missing a space before the arrow. Oh no, that's it. So go back, fix it, boom, whole thing runs just fine. The nice thing is that it can be very pedantic and very chatty. So I get this wonderful email every time I screw up. Nice red banner. It tells me I failed doing my job, which is great. But this is not every time a developer borks their feature branch, they're at least notified of it in a relatively unpleasant way, but they're notified. Again, you could do integrations with Slack and Matters Most and other fun things, or even set off a bunch of blinking lights in a server room with Hue if you're good at scripting, doing some shell scripting. But this is nice. So we've implemented a bunch of quality gates. They're checked into code. The configuration to run them every time has been checked into code. And it's running through our Git repo, which is canonical for the team. And we're making sure that a decent number of quality gates are in place and may not be breached until you get to our mainline code, and that code gets disseminated to the team. So we've erected a nice little quality gate in a wall. And that's one of the elements when people talk about DevOps. It's one of the things they keep talking about, automate the build. This is basically like having a little person checking all of your work and then compiling things to make sure it's fine. So it's kind of neat. So the other half is you can't trust ops either because they're all lazy and they don't know how to deploy software. So as we know, as software engineers, we all write perfect artifacts that are pristine and glorious and wonderful, and they all work for the first time without question in every environment that they've been placed. It's probably a bug on the operating system. Have you upgraded Node recently? So one of the first things to do is start kind of tightening up this is build your artifacts from the code. Do this automatically. Stop deploying things as much as you can. So you get this call on a Friday night and you say, okay, move the end of the sprint build to the QA server. So, okay. So okay, let me go run the build, and then I'll tar it up, and then I'll copy it to this file, and then SSH in, I go and I move into my directory. I'm hoping that's the right one on this server. Okay, I think it is, yeah. And then I'll delete the existing prod website and just untar that sucker right back in. Everything should be fine. You say, man, I hope I didn't miss a step. It's Friday night. I really wanted to go to the movies. It's the most tame thing I could think of on a Friday night, sorry. And man, I hope I can back it out, right? If something went wrong. Is RM back-outable? Okay. Maybe I should have used a symbolic link. So did that tag happen right? Did I check out the right version? Okay, I mean, it is 11 p.m. Okay, sure, let's just say it is. Man, okay, is Node the right version? Did I npm install after I did a get checkout? I hope not. I hope dependencies didn't update, and so on and so forth. So all this fun stuff starts leaping out of the woodwork, these failure modes, and I know because I've hit most of them, and I've invented several new ones, Lord knows, that have attacked me in my sleep doing deployments. This gets even weirder for Node.js, which has even more strange runtime dependencies. It's not just like, shipping HTML back and forth. So let's turn it back to our fun little YAML file. And now there's two new little bits here. And again, this is almost identical for practically everything out there. The functionality, I'm not really, again, I don't want to endorse them. I've just used them a lot, and they're really easy to spin up. I have this new step, artifacts. And so anything that's a tarball, I'm going to keep. And then down here, at the very last thing, I'm going to tar up my build code and just kind of sit there. When this process terminates, it grabs the tar GZ, and it sucks it in, and it stores it in the pipeline, so I can get to it later on down the road. The artifact is being built, so it's passed all the tests. It's running the latest whatever container I've told it, and it is built. And now I have a single thing that is that Angular production instance ready to go. I don't have to worry about anything, because if I've done it right, with this process that is continuously improving, it should be exactly what I need. So, and again, this runs off of a commit, nothing else. So it's occurring when the commits occur into the pipeline. You can also schedule this, just to be pedantic. And so let's expand on this a little bit and go actions across branches. So we've been working with this whole default thing. So you can do a lot of different things. So here we're actually on the develop branch. And maybe for future branches, we want something different. We just want to test. Develop branches, we want to do. And so now I can say that when things land and develop, now I want to do pack and publish and send this off to the actual. So I've got a local repository or something like that I want to start sharing with the team. Something lands, latest edge of development, gets distributed out. So real fast for internal iteration. Could potentially be a lot of fun doing this for publicly available packages that other people are depending on. Like Bitcoin stealing, and so I hope not. And so it's kind of neat. So this is starting to take some of the individual actions out, the manual interventions, release this out, publish this, do this and that. A lot of these things can be done automatically. It starts to get even more fun because there's usually bits you can add into these products as well. So tack a few SSH keys in. Again, when the node image spins up in pipelines, they insert the SSH keys directly into the operating system for your use, which is kind of cool. So now you can go and expand this even further and say, hey, I can transfer that directly to a server if I need to, which is kind of cool. Again, removing and reducing all these steps available. So now instead of pulling the artifact out of a website and then moving it somewhere, I can begin doing this automatically. And you can do it not automatically as well. You can actually put breaks in the system and all these other systems and say, instead of having a series of steps, you can actually have a break and say, wait for user input, right? This is now available for publication. I want to wait and somebody has to press the button. So you can do these kind of things as well. So it ends up being very, very flexible. So the example's a little bit on some greased skids, but you can put as many breaks in as necessary to support your process. And indeed you will. There's another fun element to this. Well, again, keeping track of artifacts. Like it's nice being able to pull tarball out of a particular pipeline, which is kind of fun. But they actually have full artifact management systems out there. This is an example, and again, not endorsing, but hey, I like it, called JFrog. It gobbles up Docker images, NPM repos, it does Maven and Gradle, it does PyPy, it does Ruby gems, all this other fun stuff. So actually we're taking a look at the build history for this is actually a Spring project, emitting a bunch of Maven artifacts. And so I'm keeping track of each build. They correspond to a pipeline run. I can tell who did it and when. I can take a look at the licenses inside of them and so on and so forth, which is kind of a lot of fun, as well as the individual artifacts beneath it. So you can see I've got a bunch of, Spring Boot jars sitting there in the bottom. And let's go for a little bit of a fun run. And we're going to go move down the rabbit hole a little bit further with Docker. So again, I apologize, I'm running through like a bunch of tech real quick. Not expecting everybody to implement them right away, but they do definitely help with the development and the emission of artifacts and moving them through the servers. And basically keeping customers happy is the name of the game. So there's a lot of benefits to Docker, and it's a massive topic, and I'm not going to do it justice. I love Docker. It does a lot of great things. It's also quite confusing at times, so you jump into it initially. The best part about it is you have this single atomic deployment unit. It's a thing, and it's only one thing, and it's immutable. And it is either up or it ain't, which is great. So deploying complex servers, fleets of servers, microservices, things like that, you start to worry about interdependencies. Maybe somebody's not keeping up to date with their libraries here and there. Pardon me, shouldn't have had all that soda. It boils it all down to, like, you're not managing packages, RPMs, apt, et cetera, worried about the operating system. It's a single unit that gets deployed. There is absolutely no dependencies inside of Docker. It actually is the operating system being bundled in with the entire application at the same time. No dependencies, no installation, no nothing. Single atomic unit. And they're almost comically fast. Docker containers spin up again in milliseconds, which is great. They do a lot of really fun bits with that. We did some SQL Server development before, as I mentioned. There's a SQL Server Docker image, runs under Linux. And yeah, again, Microsoft keeps weirding me out, right? It starts up in about, it's like 10 seconds. I don't know if anybody's ever actually administrated a SQL Server instance on Windows. Nothing happens in 10 seconds. Not even queries happen in 10 seconds. It's really kind of funny. It goes from cold to hot in like 10 seconds, and it's answering, which is really bizarre. Same thing happens for Postgres. Same things happen for a bunch of database technologies, Mongo and Cassandra. You can start erecting a whole flotilla of these little microservices and dependencies together very, very easily. And one of the nice things is you get to run prod from home. And this takes a lot of the edge off of moving things into UAT environments for customer tests and then to prod. The worst part is the weekend deployment. Man, everybody hates that. That's like the worst thing in the entire universe is a Saturday night move to prod. Or worse yet, is a Friday afternoon move to prod, let's be honest, right? So you can actually run the entire prod system directly on your laptop anywhere, which is fantastic. The same artifact moves, it either runs or it don't, and there's nothing that can interfere with that. Which is really, really awesome for testing. And frankly, it is super cool. Everybody loves Docker. It's a fun topic of conversations, parties, try to amuse your friends, loved ones. Talking about Docker containers is really kind of fun. And I want to take the edge off. It's not that scary, right? You're going to need to know a little bit about operating systems, obviously, and file systems. Yeah, sorry. But there's not much to it. They basically end up look like little tiny virtual machines, but they're driven by a text file, which is kind of cool. You never actually are supposed to kind of get into it. Yeah, you can open up the hood and kind of dabble, but you're not supposed to a whole lot. The files are really simple. So I'll boil it down real quick so nobody falls asleep, but I'm just going to say Node 10 is the version I want. It's going to track latest version of Node. And then there's a certain number of commands I can run that are blessed by Docker. And I'm going to make just runs a shell command, make a directory, change its ownership. Internally, I'm going to be this user called Node. So Node doesn't like running as root. So I'm going to change my user. I'm going to copy dot, which is my local directory, into that directory I just made. So I'm just copying my source code into it. And then I'm going to internally change my working directory internally to /node. Okay, that's fine. There's this fun little bit here, and I put the comment in with npm rebuild. So when you're in this container, you're running in that container's operating system. If you're doing development under macOS, macOS ain't Linux. NPM, again, as in my previous talk from an hour ago, has a whole bunch of C++. If you've ever dabbled with Node, you'll see G++ rolling by all day long with Node JIP, which is a really weird name for it. So if you change operating systems, thou shalt recompile, right? Ask me how I know. It's a really interesting thing, because when Node fails due to a compilation, it fails at the point of entry, not initially on startup. So it'll run flawlessly for days until it hits that one module, and then it'll crash spectacularly every single time. So there's some things you got to be aware of. Is this, well, when you stamp things in a Docker, it stays in that operating system that it's attached to. And so you can actually, these are all open source too. You can pop open the Node 10 Docker file. Node publishes it. It's available for look, and you can see how they erect their virtual machine, their whole Docker images. It's a great way to learn. And just from putting these things together, a lot of these guys are miserable at it, right? You look at the Nginx image and you go, what are you thinking? Same thing for the WordPress image. Ken and I had some fun with that. You go, why is this? Who designed it to do? Oh my God, that's just crazy. So just be on your guard a little bit. This has the same issue that people do when you're buying, like getting NPM libraries. Sometimes people are really good at it, and sometimes people are pretty bad at it. But always keep an eye on the provenance of the images that you're using and leveraging. Sometimes the vendor images are honestly not the best, and you might want to roll your own. So we've had to do that for a number of them, actually. And so down here at the very bottom, the entry point to the container is the program called Node. That's it. And I tack on a use strict because I like that. And so when you run the Docker container, you just give it a single argument, and that'll be index.js. So you can change this file so that it always runs index.js. If you have multiple entry points, multiple files to start, you can do some fun things with it. It's basically like having a command line operating system. And on the Angular side, it's almost completely identical as well. So you start with Nginx, and most likely you're going to want to do a little bit of configuration shenanigans, because if you get to a URL that's routed, you don't want a 404 out. You want to redirect to index.html. So there's some bits you want to do in configuration, but they're not terrible. And Stack Overflow here is your friend. So here I'm just copying the dist directory from my compilation target in Angular directly into /static, which I define on my Nginx config. And then I turn on Nginx. No problem. Self-contained web server. So this is kind of neat. So we have these deployment artifacts that are actually runnable full copies of the operating system that are immutable. So cool. Well, let's go tie some of this fun stuff together. And there's a neat little bit here, pipelines, turning Docker on. So we're in Docker, and we're turning Docker on. So now we have Docker and Docker, which is at least one more Docker than you're normally used to. So you can actually Dockerize all your Dockers. Again, fun at parties, amuse your friends, confuse your enemies. This at the very bottom here, you'll see I'm actually going through, and part of my build step, truncated, I'm doing a Docker hub logon. I'm building my images in the source code, and then I'm pushing it directly out as an image, which is fantastic. Again, this is happening per commit, landing and develop, or in this instance on a default branch, so which is just an example. But I'm starting to remove all of these bits now. I'm starting to try to collapse all the elements together into as few moving parts as humanly possible. At the end of this, I have picked my operating system. I've built my Angular repo. I made a production build of it. All my quality gates have been met. And I attached the two together with Nginx and Docker, and I have a single immutable deployable element that has been built for me based upon the last commit that has passed all quality checks. And this is fantastic. Now I can start to be fairly certain what I'm deploying is what I want to deploy. And hopefully it'll stand up rather than fall down. Don't have to worry about the operating system that it's going on. And some of the end game starts to look like this. Again, this is dog fooded from our server for the spa day thing. And this is a full-blown run from the Chariot Spa server. Runs through all the lints, does the audit, runs the test, et cetera, et cetera. And at the very end, it just pushes out a development image version for the rest of the team to build their, the Vue, React, and Angular apps against, which is pretty cool. Now, one of the nice things about this, again, with the whole Docker bit, is that you can do fun things with erecting the entire stack, the front end, the REST server, the backing database, all the other secondary microservices if available. Spin them all up in a couple microseconds, on a server and then test them completely end-to-end back and forth in a full integration, and then destroy them when you're done. Again, this is sort of in the path of continuous quality. We're starting to talk about doing a full-blown end-to-end test. If you're doing things with Selenium, you can drive the whole thing from a user perspective automatically in test, lights out, which is pretty darn cool. And you can target this per commit or on a schedule as necessary. It's actually really neat, and it gets you on that path for continuous delivery and continuous quality. The ultimate bit about continuous delivery is when a commit lands, is that it goes to prod within the same minute or two. And that's the ultimate goal that a lot of these things like Netflix and so on and so forth have achieved, but they do it through massive amounts of internal quality systems in place. But allows them to react when things go wrong in prod, they can react exceedingly fast, like staggeringly fast. And it takes a very long time to get there, but that's some of the end goals of this DevOps. So, and yeah, so keep up with the quality gates. Use all your linters, use all your tools as much as possible. They're fun, they're really painful. I personally despise them, but they keep me writing good code. And they certainly keep me putting my spaces between my arrow functions because it won't let me not. But it's nice for the next person who picks up the code base and doesn't see a whole bunch of bizarre indentations between two spaces and tabs. So you can enforce a lot of these qualities in code formats automatically. Try to automate as much as possible. Get human beings out of the loop as much as possible. Begin emitting artifacts that can be used down the road that require less tenuous grip on build systems. I worked at a place a number of years ago that was it was a .NET shop, and it only built on one person's laptop. And that's real. Like that happens surprisingly often, where somebody, like there's a hard-coded reference to G colons, and you're like, who the, oh my God. Like things like that actually do happen. So, I mean, automating builds, getting this out into the cloud, into Git, means that you can stand up development real quickly anywhere, and new engineers can come in and just off you go, and the gates are already there, which is great. And remember, configuration is code. Check everything in as possible. If something needs knobs and dials twiddled on a website or an interface or something like that, rethink that tool if humanly possible, or better yet, automate it with Selenium or Puppeteer so you can check in the code as configuration. There's a lot of fun things you can do to force things to your way of thinking if necessary. And you know, this starts to expand out. You begin looking at things now that we're building things automatically. It's real easy to begin doing configuration check-ins and maintaining things for, like, you know, the Elastic containers, you know, EBS, EC2, ELB, RDS, ETC, blah, 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 the entire alphabet soup that is Amazon AWS. There's nothing wrong with doing things, you know, with like a full-blown CloudFormation, Terraform, GDM configurations. These can all be checked in and automated. So like the concept of standing up another production on Friday should be pretty easy at a certain point. So a lot of the fun end games with this, you start playing with Docker, start to look like Kubernetes, which is a really fun tech stack to play with. It's a little daunting, but it does blue-green deployments automatically. It handles all kinds of interesting things, and it'll roll back entire suites of configurations of servers, which is pretty darn awesome. It gives you some kind of incredible rollback button in case production starts to go a little weird. And of course, integration, you know, if you're playing in an enterprise, not everything's going to be running Kubernetes. You may be interfacing with ServiceNow and ITSMs, you know, playing with vRaw and vRow and other enterprise stacks. You pull down documentation. All of these things are deployable. All these things are automatable. They all have SDKs available to poke and prod at, and they can all be leveraged. And honestly, wherever you go, there's always something you can do with this. It's fun being able to break out of the traditional role of a server and code and deployment guys and having, you know, the tree guy and the disk guy and the database guy and so on and so forth. And start merging these things together in a cohesive team that's trying to get things out to prod good as fast as possible. The name of the game is keeping customers happy. We're all employed for a reason, which is really, the bottom line is to generate revenue. And really what this boils down to is helping you achieve good revenue through development and getting those targets out, which is really what the most important part about DevOps is, reducing the bottom line, improving the development cycle, and also making people happy, which is also pretty important. Not that happy, the other happy. So never stop improving. That's DevOps in a nutshell. So I hope you enjoyed brief tour of some tech, and hope you guys get to use it. It's fun.